Hello everyone. In this section, we'd like to study the Gaussian integrals. It's quite difficult to perform these integrals. So I'd like to show you how to calculate these Gaussian integrals. So in these cases, we consider the integral with respect to x. So if you write alpha x squared dx, so you could change this x to the y, 0 to the integrals, exponential minus alpha y squared dy. Of course, these two quantities have to be the same. So we can write under these equations. If you take a square root, 0 to the infinities, this is dx, 0 to the infinities, dy, exponential minus alpha x squared, exponential minus alpha y squared. Okay, we could write under these equations this way. So this is exactly equal to the 0 to the infinities dx, 0 to the infinity dy, exponential minus alpha x squared plus y squared. We'd like to perform this double integrals. So if we consider the x and the y planes, so you can draw these planes. X and the y planes. And we'd like to integrate over these planes. So we'd like to draw the two x and the y, 0. So xy planes, we'd like to integrate over this region. X is changing from 0 to the infinity, y is changing from 0 to the infinity. So it's covered these regions. Okay, these integrals. And then we'd like to change the Cartesian coordinate to the polar coordinate to perform this integral. So instead of x, y, we use r and theta to describe the positions in the planes. Then integrate double integral formulas. You could consider small areas. Then this length is expressed as dr. This length is expressed r d theta, because this angle is expressed d theta. So small areas covered by these regions is expressed r d theta times dr. Okay, in the case of the Cartesian coordinate, with the dx and the dy, so this means take x and the y. So this region x plus dx and the y plus dy. So considering this small area, this region is expressed areas of this small region dx times dy. Dx times dy, dx times dy corresponding the small regions in the Cartesian coordinate. Also in the polar coordinate, we could consider small regions. Then we'd like to change these expressions. Square root. Dx and dy areas can be expressed r d theta dr. These are small areas. And the exponential terms, we'd like to change this exponential. And the x squared plus y squared is exactly equal to the r squared, because this is x, this is y. So Pythagoras theorem, so we can apply it. X squared plus y squared equal r squared. So this region becomes minus alpha r squared. Then we'd like to write down the range for the thetas. theta is changing from the 0 to the pi over 2. So this is 0 to the pi over 2. For the r, dr is changing from 0 to the infinities. 0 to the infinity. Okay, then we could perform this integral, exponential. So for the thetas, it just becomes pi over 2. For the r, here this is r, this is exponential r squared. So it becomes minus 1 over 2 alpha exponential minus alpha r squared. So if we have a difficulties, you can find the derivative of these functions. It becomes actually exponential minus alpha r squared times r. You can confirm. The lower limit is 0 to the infinities. Then its answer becomes square root pi over 4 alpha. Okay, so we could confirm this equation. Answer becomes the square root pi over 4 alpha. So I have proved this formula for the Gaussian integrals. And another important formulas I'd like to prove that these ones. Often we encounter these formulas. We have proved 0 to the infinities exponential minus alpha x squared dx is becomes square root pi over 4 alpha. We have proved these formulas. Then we'd like to actually find the derivative, partial derivative with respect to alpha in the both sides. Then we'd like to perform this derivatives. It becomes derivative with respect to alpha. So alpha, it becomes 0 to the infinities minus x squared exponential minus alpha x squared dx. The derivative with respect to alpha, you have to x squared is gonna be appears here. And the right hand side becomes minus 1 over 2 square root pi over 2 1 over alpha 3 over 2. Then you can actually this negative sign becomes positive. So finally integrals x squared exponential minus alpha x squared dx. It becomes square root pi over 4 1 over alpha 3 over 2. Okay, we could prove that this formula. So using this method, also you could easily find out these integrals x to the 4th exponential minus alpha x squared dx over x to the 6th exponential minus alpha x squared dx 0 to the infinity. Blah, 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 blah. Okay, this is the end of this session.